U-locks come in various sizes so that you can lock your bike to different structures, from thin bike racks to thicker tree trunks. The shackle and lock are made of hardened, high-alloy steel, which is resistant to cutting, sawing, and twisting. To shape the shackle, workers load steel bars into a computer-guided bending machine. The machine applies more than 25 tons of force to bend the bar into the shape of a U. The machine also notches each end of the shackle. These notches are what receive the locking bolts. To make the steel hard enough to be tamper-proof, they send the shackle to an outside facility for heat treatment. This demonstration recreates a small part of that complex process, which is to heat the shackle to about 800 degrees Celsius to rearrange the molecular structure, cool it in oil to set the hardness of that rearrangement, then reheat at moderate temperature to restore the flexibility the steel lost due to the previous steps. When the shackle returns to the factory, a laser machine precision measures and, if necessary, corrects the dimensions as per specifications. Then the shackle is dipped in durable anti-corrosion paint. Once the paint dries, an automated machine slips a PVC tube over the shackle. Next, they screw a plastic bracket to one end of the shackle. This connects to a corresponding bracket you screw to your bike frame to mount the lock on the bike when you're cycling. The rectangular block that houses the locking system is called the lock body. It too is made of hardened steel. An automated press punches holes on the ends for the shackle and in the middle for the lock cylinder. The locking system has a housing in the center for the cylinder. Workers mount two metal plates over it. When you insert the security-coded key in the cylinder and turn, the cylinder rotates within the housing, and the plates move apart, triggering other components to lock the inserted shackle. The cylinder is made of brass, a relatively soft metal. So there's an impenetrable steel plate on top to prevent a thief from drilling into it. Workers give the cylinder grooves a squirt of grease, the housing as well. Then insert pins into the grooves. These act as blockers, preventing the wrong key from opening the lock. With the correct key, they give way, enabling the cylinder to rotate within the housing. This spring applies tension to the cylinder's steel anti-drilling plate, keeping it in position, so that the key inserts easily into the cylinder. On each side, workers insert a lever and bolt. When you turn the key to the lock position, the lever pushes the bolt into the shackle's notch, immobilizing the shackle. This component spring-loads the bolt to prevent the inserted shackle from popping out prior to being locked. A pneumatic machine inserts the locking system into the steel lock body. A two-tone plastic cover gives the U-lock a snazzy appearance and makes the surface easier for the cyclist to grip. Here's how the lock works. When you turn the key, the cylinder rotates. This moves the two plates over it outward, triggering the levers on each side to hold the bolt in the shackle notch, locking the shackle in place. Every lock undergoes an opening and closing check. Random samples are subjected to more extensive quality control testing. It takes 13 tons of cutting force to break the steel, far more than even this larger than typical bolt cutter can apply. This torsioning machine measures how much twisting the U-lock can withstand. A bike robber would have to apply more than 160 kilograms of force with a crowbar. The bike owner, on the other hand, needs only the coded key.